Hey guys, and welcome to Functional Print Friday, and welcome back to my shop. So on the workbench this week is the remains of the very poor quality attempt I made at making a chip shield for behind my milling machine some time ago. And this was made from cardboard, 2 pieces of Coroplast that I scavenged off my yard that someone had stuck there to advertise their business. And we actually stole, this is Coroplast. This is the same material that we made the 3D printed enclosure for the fiber laser out of. And that's why this side is missing, because I stole that piece off of there when we were prototyping that design. And I've never fixed it. And every time I use the milling machine now, I sort of block chips behind it and on this side, and then they just go flying all over the shop on this side. So I guess first let's walk over there. I'll put this back in place and just kind of give you an idea of what I'm trying to accomplish with this. And then we're going to figure out how to remake this a whole lot better. All right, so I set the chip shield back in place, and you can kind of see how this thing works now. It's basically just blocking chips that fly off the cutter. I don't have anything in here now, but typically there'd be an end mill or a face mill or something in here. And as the chips fly off, they'll bounce off onto this and down on the workbench to clean up rather than hitting my truck, or if the truck's not in here, going halfway across the garage, then I have to sweep the whole floor every time I use the milling machine. And of course now we have no protection on this side at all since that piece is missing. And if we look around the back, you can see that the cutout here is just for that wire, the power wire for the milling machine to come down over the edge of the bench so that this doesn't just try and slide off the back of the workbench. Now, for the incredibly low effort I put into this, it actually worked kind of okay, at least until I stole that side of it. But it still has some problems. You can see we should be a little bit higher. So this is, I have the head of this milling machine as high up as it'll go. I could technically go higher, but then the dovetails wouldn't be in full contact, which is less than ideal. So you figure that is really about the highest position that we would have a cutter in, and usually the cutter extends down a little bit. So I think, just kind of looking at this, I think like the height of our cardboard is probably okay. I'd want to go a little higher just in case chips kind of came off at an upward angle. This is definitely too low. And there's some other shortcomings as well. Like I made this out of just 3 pieces of material. I think it needs to be more. The back definitely needs to be wider, but in addition to that, I think I'd like to have another hinged section. So maybe 1, 2, 3, 4, 5 hinged sections total. And that is because this table ends up going pretty far to the left or pretty far to the right if I'm using the whole table. So I think there'd be some benefit rather than having to move this whole side way out to accommodate that coming out versus just having like a segmented section here that allows the protection to still be a little bit more complete, because now this is totally open over here on this side. So whatever I have on this end of the bench is still getting covered with chips. So I think the next step is to think about what materials do we have to work with. I had originally gotten a bunch of white Coroplast that I was going to build the fiber laser enclosure out of, and then we ended up getting the black, partly because the black just looks really cool, but also I think the black does a better job actually blocking the dangerous light that we're trying to protect ourselves from on this enclosure. And by the way, I use this enclosure all the time. I know you guys probably wonder, the stuff that we make on the channel, how often does it actually get used? This thing is great. I have it set up, the laptop's always here. I flip that button here on the power strip, laser comes on, the lights inside comes on, exhaust fan comes on, and I can just run code right away on this machine. It's been extremely convenient. I've got a whole video on this. If you're watching this video and you have no idea what this thing is, I will link to this enclosure down in the description of this video as well. So I think what I want to do is design some hinges for the Coroplast. So we'll have the 1, 2, 3, 4, 5 pieces of Coroplast, and I'm thinking we'll have hinges, maybe one at the top, one in the middle, one at the bottom for those panels. And we should probably go up to the barn and get the white Coroplast, because I know we have good geometry on the design for the enclosure. Like we have a nice slip fit of this Coroplast into these edge pieces. Like it goes in, stays in place, but doesn't deform the material, and then screws lock it in place. I think we can steal a lot of that. We probably don't need everything to be as beefy as the corner pieces on this, but I'm not 100% sure if this was the same thickness as that. So let's go get the Coroplast, and then we'll figure out how we're going to do the hinges. While we're up here, I'll give you a quick update on the solar. I had borrowed this folding portable solar panel from a friend of mine. I believe they're 100 watt panels each, so a total of 200 watts. And I've got that, it's just getting to the point where it's getting shaded here now, but this was the spot that was most ideal for me to get the most sunlight, because it still doesn't make sense to try and get up on the roof of the barn yet to put panels on the roof. It's still too cold. And the panels are going to go on the back of the roof, not the front here, because I think the back is going to get more consistent sun. I'm definitely going to have some shading from that tree, but I think it's still going to be better than putting them on the front, and I also won't see them if they're on the back. This Delta Pro 3, though, has been really great. The only issue I've run into with this is temperature, and that's actually why it has one of my kids' old blankets wrapped over top of it, is because below 32 degrees, and not like below 32 degrees ambient, but when the unit itself, when the battery's inside, there's temperature sensors in the batteries, get down to 32 degrees, they stop charging. So just putting a blanket over it, which I actually found as a recommendation in the EcoFlow subreddit in the winter, seems to be minimizing the heat loss enough that that is not an issue. And before you wonder, is it going to potentially overheat now if this thing sees an unexpected amount of load? No, because the blanket doesn't cover any of the vents. The intake vents are on the front and the rear of the unit, which are not covered. This just minimizes the actual heat loss through the through the material itself. I will put a link to this down in the description of the video, but if you're interested in one of these units, I would say wait, because I'm going to do a full review and test on this guy probably sometime in April. I want to wait until I have the solar panels up on the roof. And right now, we are putting out like 630 some odd watts, and that is actually just the lights in this building. Believe it or not, these huge high bay LED lights draw a fair amount of power, but I mean, they're also providing really good lighting in this large building, so I can't complain. But I want to do a lot of testing on this guy. I want to try running an air compressor up here. I want to try running a bunch of power tools, and might even try a welder up here as well, because this barn is not connected to the grid at all. We are almost 300 feet from my house, and there's no wire that comes up here. This is the only thing that provides power up here in the barn. All right, I think that coroplast is hiding in here, and yeah, and I have 2 sheets of this. Yeah, this is going to be crazy trying to carry this back in this wind. So, all right, I'm going to put you guys in my pocket, and I'm going to try and get back down to the garage without getting blown away. All right, I made it back alive with our coroplast sheet. Let's just see here. Yeah, I'll have to double check my measurements, but I'm pretty sure that the 4mm black coroplast was also kind of the same thing, like 3.8 something or 3.9 something. So we should be able to reuse the same geometry to get a nice slip fit on this material. So I think what I'm going to do next is get this guy out of the way and maybe just take some masking tape and try and tape out the sizes that I want this to be for the panels. And then we're going to start thinking about how we're going to design those hinges, because while I was walking back with the panel, I thought, we don't want the panels to have gaps. Like, I was just thinking of an easy hinge where we have a single design that sticks out past the edge. You print the same thing on one, you stick it upside down on the other one and just have a pin going down through. Maybe we even use filament. But if we do that, there's going to be a gap between the panels. So I got to think that part through. Okay, so I've been playing around with this blue tape for a little while, and I was initially thinking that I wanted both sides of this to be the same, like mirror images of each other. And I've gotten away from that. There's really no reason to do that. As long as no other panel is longer than the panel on the back, this thing will still fold up pretty small. And I do want this to be able to fold up because I want to be able to store it up there. I want to just be able to slide it up onto the top of this big steel cabinet behind the milling machine so it's out of the way when I'm not using it. So I think the back is really only going to come kind of as far as the chip tray, and there'll be a fairly long panel here, a fairly short panel here, and that gives us enough clearance even to have my hand there, or pretty much there, even if this guy is all the way to the extreme limit, which rarely happens. I do use a good amount of the envelope on this machine, but I don't usually have the table all the way to the very edge like that. On this side, we can have shorter pieces because I can't really protect from chips over here anyway with this guy extended out any further than as far as we can go with the barrier anyway. Because if we, let's just try and guesstimate this. If I take the tape here, so from the casting to the edge of the handle is a little over 2 feet. It's going to be the same on this side. So that 2 feet, yeah, puts us out over here. We're way over the floor. So I don't really need that length here, because if I'm going to extend the table as far as I can in this direction, this hinge is going to have to be open anyway, and this is just going to be hanging off the edge of the workbench. And I'm sure at least one person is going to ask why I don't just remake this with the correct size panels that don't have someone's advertising on them and tape it. again. And the tape worked okay. I had to fix the ends a couple times. Even in the few times that I used this, it did start to tear. And you can only fold these in one direction. The tape doesn't like to go the other way. So I think I've kind of wanted to design some 3D printed hinges anyway. Even though we're going to use them just on this today, I think there's going to be lots of other applications for hinges that will key right on to coroplast. So I got to figure out again though how we're going to do that and not have a big gap on those panels. Maybe we can have the hinges like come at some kind of an angle so that the panels overlap each other. And I got to think about that. All right, welcome back. I ended up going in a very different direction from what I originally planned on this. I started drawing sort of just a classic hinge that had like sort of a wrap around, like a mirror image of each other to minimize the gap in the panels. And I realized no matter how I did it, I'm still going to have a gap in the panels, and or the panels are not going to fold flat in either direction to store. And it occurred to me I might be missing a much easier solution here. What if we did a live hinge? What if the material itself was the hinge? So I drew this one first, and my thought is to just print this whole thing out of TPU. And we don't actually need this material for it to fold around on itself flat in either direction, but I'm trying to leave enough to spread out the, sort of the flex across a longer surface or a longer length of material versus it trying to bend really sharp in a short distance. And I designed this initially at 1 millimeter. That's the thickness of our live hinge. And I thought, you know what, let's just try and make it 1 extrusion width. So this is the same design, but I've made this 0.24 actually. And the thought here is that should be small enough that in the slicer we end up with just a single extrusion width. I'm a little bit concerned about the strength of sort of the handoff between coming down from multiple extrusions to this single extrusion width, but TPU is pretty tough stuff. Let's give it a try. This also should not take too long to print. And I transferred the geometry from our custom enclosure build for the screw holes over to this because I already know everything lines up with those particular type of small screws. I think we're gonna have to get shorter ones from what we used before since the thickness of this is pretty minimal. But that should lock the coroplast in. Because of course this being TPU, this is gonna, we'll be able to spread this open. It's not gonna slide on as tight as the PLA pieces that I was originally thinking of. But yeah, let's print this out. Let's see how this goes. I have seen people do live hinges before, but I don't know that I've seen one done in TPU. So let's give it a go. All right, so our first test piece is done. And if I sound surprised, it's because I am. I really wanted to try this, but I didn't expect it to work this well. Like this thing came out really nice. The only artifact I see at all in this is, actually I don't think it's just, I was originally thinking maybe we did start to miss the edge a little bit about in the center there, but it lines up perfectly with the artifacting on these pieces as well. I think that's just where the screw holes are. I don't know if the camera's picking that up. You can see a line that sort of runs all the way across. I think it's just a change in the tool path from when it had to print the screw holes. But this looks really, really good. Now, these are overly flexible. Like this is not going to grip onto our coroplast, but that's okay as long as our screws do bite through and grab on the other side of the TPU. And I've got a scrap of coroplast here. I cut up all of our coroplast panels. They're sitting over there just out of view while this was printing, so they're all set to go. Yeah, it slips over nice. It's actually kind of snug on there, but I know, I can force it open pretty easy. Just the action of bending this opens this guy up. So we definitely need the screws there. And that'll keep these from sliding as well. But I think our success here is short-lived because as amazing as this is, and I still really like the live hinge idea, but I don't think this is going to scale. Because this printed just fine in this height. This material still has a fair amount of rigidity in Z at this height. But imagine this stuck to the bed, and now we're 100 millimeters up, 200 millimeters up. We could even do 300 millimeters in one piece on the Qidi Plus 4. And this one's printed on the Qidi Plus 4. That machine does a great job with TPU. I think this is going to flex too much. I think that as the extruder is up here, that this flexibility is going to add up, and this guy is going to be like a spring at the top. And even if we get the TPU to stick well, it's not going to be consistent. We're not going to have a flat face, and this is probably going to fail. Between the flexibility of this adding up as we get higher and the flexibility of the side pieces, I think even if these succeed, they're not going to look good, and this is going to fail. I am tempted to try it, and I've thought of how could we maximize our chance of success, and nothing says this needs to be a straight line. We could redesign this to be like this, or even like this realistically, but we can't connect these two. So, I mean, like probably about there would be the most chance of success of this completing, but there's still going to be flex especially at the edge up here at the top. Like as this goes up, we're still going to have a lot of flexibility in this part on either side as we try and lay down that filament. I've got another idea. I think we can take this idea of the TPU live hinge and hybridize it with PLA. And no, we're not going to do it multi-material. We already know that from, just from the last couple of videos we did that that's not going to work very well. But what if we made these side pieces out of PLA, extended this a little bit further, so we had a little bit more space to work with, and then we had the flat TPU with like a triangle on the end, and we had the inverse of that triangle shape into this piece so that it would slide down in almost like kind of a triangular track. And it would be encapsulated in there. Like we wouldn't be able to pull it out. It's gonna lock in place. We can't print this standing up, but I have an idea of how we can still incorporate those triangles and get the flat TPU piece. I think so anyway. It's working in my head. Let me go see if I can get it into CAD, into something I can show you guys, and then we'll print it and try it out. All right, welcome back again. So I think this illustrates what I was trying to explain a bit better. So imagine this gray part is our solid material. This is PLA, PETG, doesn't really matter. Some sort of rigid filament. And the orange part is our TPU, and it would slide in. So this is just ever so slightly smaller than the actual opening here in the rigid material, and we'd slide it in from the end. And as long as it is a snug fit, it should pretty much stay in place on its own. Now, the challenge that I can see already with this is, this will be easy to print. So if I get rid of this, that's going to print no problem. And we can print these, pretty much the full height limit of whatever printer we're printing them on. And that should be fine. But that TPU piece, we can't print this standing up. That's not going to work. I mean, we'd get maybe 10 millimeters off the bed in Z, and then this guy's just going to be flopping all over the place. But what if we rotated those triangles around so that the whole bottom was flat? This is the exact same geometry. All I did was I just copy and pasted it, and then I rotated the triangular pieces around until one side was completely flat. Yeah, it's going to have a little bit of preload, I guess, in the hinge, but I mean, TPU is incredibly flexible, particularly at one extrusion width, as we already saw. So I think this might work. And if it does, we could basically print the hinge part, the TPU part, as long as the bed is in length. So, if we put it at an angle, we can easily print this guy even taller in X or Y. Then we can print the other part in Z. So let's give it a go. I'm going to do the same sort of short test. We'll do just this piece. I think this is 25 millimeters tall, and we'll do one of these in 25 millimeters height, which is actually going to be flat. And we'll see how it goes. The one thing that's going to change is one side of this is going to be down on the textured bed, so this side will have a texture to it. This side will see the surface finish of the tool paths. I'm not really worried about the surface finish or the appearance. It is going to change how this works. The other one was layers bonded in this direction, so we were pulling in the same direction as the tool path, so it was very strong. I think we're going to have pretty much the same strength here because TPU bonds to itself so well, and again, it's just such a durable material. I think we'll be okay, but let's hit print and find out. All right, those test parts are done. but I'm a little concerned about our TPU piece. So again, we printed this flat. Instead of standing up like we did on this one, we now printed this flat down on the bed, but the triangles kind of don't really look like triangles. They look a little bit distorted. I don't know if the camera is picking up on that. I think it still might work. And it might just be, you know what, I think it's just because, you know, of course they're laying over on their side, so it's just, I can't really make it flex perfectly at the edge because I can't, you know, I can't like clamp this triangle and just between my thumb and forefinger and get it to bend just right. Let's just try it. Ooh, wow. That actually fits in there really nice. See if we can get it on the other side. See if we want our screws on the same side. That one feels a little tighter. Maybe it's just because I fed from the other side. Wow, actually, I think I like that even better than this one. And it looks like we're keyed in there really nicely. Now, you know, these are only like, you know, maybe 25 millimeters tall or something like that. So I guess it remains to be seen how well the TPU is going to slip into our triangular track when this guy is full height. I think we'll probably do these 250 millimeters tall. That way I can run the PLA pieces on my P1S and my X1C while the TPU parts run on the GD+4. But yeah, that is, I wonder if we could pull this out. I can't get it to pull out. I mean, I'm sure some amount of force is going to cause this guy to come out, but you can see how much that TPU is stretching. Or if you can't here, I'll do it at an angle. That is honestly working. This is working way better than I expected it to. I thought we may end up with kind of a loose fit in there, but I figured, you know, the full length of it is still going to make it plenty strong enough not to pull out. But this is just a tiny little test sample. Let me put this in the vise. And I'm realizing a flaw in this test. So when I squeeze it in the vise, it's actually squeezing this side, which is going to cause, it's going to hinge there. It's actually going to cause that to open. I guess I could slip something in there. Now, let's just put our coroplast in. Now, because of the way this is corrugated, that should actually be pretty stiff. This will let me get a better grip on this. Let me reach around you guys. Let me see if I can actually separate this. All right, sorry about that. It slipped out of the vise and I knocked into the tripod, but you saw how far that was stretching. And look at that, it even went right back to the same shape. So yeah, I think that is more than strong enough. Let's try scaling this up. All right, I've got some full-size pieces done. I tried the Super Tack sheet from Bamboo for this without any brim because I really didn't want to be cleaning up brim in and around all these tiny features here. And it didn't work out so hot. I don't know, maybe I'm using it wrong, but this detached from the bed at only maybe about like this high. So I turned a brim on and printed this on just the regular textured PEI sheet, and that worked fine, but they were a pain to clean out. So I want to address that and see if maybe we can design our own brim pieces that are going to be easier to get off, because I spent probably 2-3 minutes a piece cleaning these up, which is not the end of the world, but I'm going to have to make a lot of these for this project. So we'll have to address that. All right, let's see if these fit. So this came out nice. Now, this is what I'm worried about, is if we can still get this to slip in at full length. To make sure the end is nice and clean. For whatever reason, this feels a little tighter than our test. Oh, you know what? Actually, we could probably exploit that hinging that I was talking about before with the vise. Yeah, if I squeeze this, that actually slips in a lot easier. I wonder if I can fit this whole thing in my larger vise over here. That might make it easier to feed these in. All right, here's what I'm thinking. So this vise is still not as wide as the piece, but I think it's going to squeeze most of it. If we slip this down in just a bit. Now, I know you guys can't see the end of this, but I am turning this just till I see it kind of pinching it. Oh, there we go. Wow. All right, I think we solved that one. All right, well, after some trial and error, I think I have a process here now that works. The problem I was running into is, well, there was two main problems. One was there was sort of a little bit of a booger of TPU on the end that I wasn't seeing that needed to be snipped off that was holding us up on both the first side and the second side. So we'll have to make sure that those are trimmed on the end, which makes sense. At the very edge of the print, it was just raised up a little bit, and it was bigger and didn't want to start, and was also getting hung up at one point on the bottom piece. And then the other problem I was having was the amount of tension to put on it to open it up was not enough that when I was trying to pull up across, that it was keeping it from coming out of the vise. By adding a stop block here, I'm pulling against the stop block instead of counting on the friction of the part in the vise. So I think we should be able to assemble these no problem now. And I'm really excited about this, not just for this project, but what this means for other designs as well. I think we could sort of copy and paste this idea of having this triangular channel and triangular ended TPU live hinge for all sorts of stuff, like enclosures, boxes, all sorts of things where you want a really durable live hinge. All right, and all that fidgeting about trying to get the process down. For this, I actually put that the wrong way. I think I want the screws on the same side. The other thing I'm noticing looking at this is, I just did this as a test, 250 millimeters in length for both the PLA part and the TPU part. I think I want to make them different lengths. There's no reason to have the seam for both parts at the same point because this is going to continue on. I want to be, I think, 650 millimeters high. If we do the TPU, say anything, like even 20 or 30 millimeters longer in length, then the TPU will span to the next part of PLA, and the seam in the TPU will be at a different spot as the seam in the PLA. I mean, we're going to get most of our strength from being screwed into the coroplast anyway, but I think that'll additionally help us even get this together. And maybe we trim the track off the ends and have even an overlapping part. Like, I don't really have a way to show it to you what I'm thinking, but what if we trimmed the track off the ends and had just an overlapping part of TPU as well to even further keep chips from getting out of there? All right, I think it's time to scale up again. I think I'm going to start, I'm going to adjust the design for the TPU insert to be a little bit longer, and I'm just going to start printing a whole bunch of these pieces. Let's actually test this on the coroplast. Just make sure that our PLA one is still a good fit. Oh yeah, that's a nice snug fit. I mean, again, we could probably, just like on the enclosure, we could probably even skip the screws. But I think putting the screws in will stiffen it up even more. That's a nice firm slip fit on the coroplast. All right, I'm going to make a bunch of pieces, and I'm going to bring you guys back. All right, we got a bunch of pieces here, and I mentioned I was going to try and come up with an idea for the brim that we didn't have to clean out of the little triangle area and the inner part here. Yeah, I modeled the brim separately, and it's perfect now. It actually breaks off. I made it 2 layers high, so there's actually a little bit more leverage to grab onto it for it to break off, and it comes off super clean. So I turned that 3-minute job per part to basically 3 seconds. Okay, well actually that one, it's even still pretty clean. So I don't think we're gonna have to do any deburring or additional cleanup on those. So, all right, I've got a whole bunch of parts to put together here. I'm gonna get the camera off to the side, and I'm gonna start assembling all this. All right, at some point the camera battery died and it turned off, and I didn't notice. But this ended up being quite a bit more fiddly and tedious than I anticipated to get one of these together. And that's because all my planning went out the window as soon as I got to the second segment, which you guys probably saw coming. But yeah, once I got one all the way together and actually put the panels on, yeah, it's totally worth it. This works really, really nice as far as a live hinge. Folds both ways. It supports the weight of the panel. I mean, it works really well. So it's definitely worth it to do. And I did overlap pieces just as planned. And I made sure they're facing the same way so that if I ever use coolant on this machine, that everything drains down one face of these panels rather than sneaking around to the back. So yeah, I think I'm going to put you guys back in the tripod. I'm going to put some music on, and I'm just going to power through these. I'm sure I'll get faster at each one. But yeah, this one took me probably 10, 15 minutes to get together, which isn't great. But I think if I apply what I learned from the first one, I could probably get the next one done in 5. All right, I brought you guys back for the very last part of the last one here because I definitely got a lot faster at these as I went. I think I got this one up to this point in about a minute. And some of the tricks I just want to share with you quick here in case you do decide to build one of these yourself. It really helps to use spring clamps. In fact, if you didn't have a vise, you could probably just do this with 4 of these spring clamps. These guys on the end make a big difference. This material, even though it's not that far out of the vise, it's not really opening up at the end, which was part of the problem. The other thing that's really important is actually prepping the TPU. So let's pretend that this was going to be the end that lined up with our PLA piece. So for those, I'm prepping them like this. I just snip the corners off in both directions, just like that. And I'll actually do a little bit sort of on the triangle as well, just to make it even easier to start. And that makes a world of difference. That'll start right in there, no problem. Now, if this is a piece that's going to overlap, so I also prepared the ends this way for a join, but not the part that's actually going to overlap. The piece that's going to overlap, if this was instead the part that I'm going to join to this, I do sort of the same thing, just a little bit longer. So let's cut this back off straight so I can show you. That's good enough. So these are just regular snips, the same kind you get with many 3D printers. And I'll cut it at pretty much the maximum length that these guys will do, at about that angle. I do the same thing over here, just like that. And then I trim back the triangular section a little bit as well. And then when I feed that in, I feed it up to the piece that I'm joining, and I bring sort of the triangular rail part up to meet each other, and then this is the part that actually overlaps. And you do want it cut sort of in that shape, otherwise you end up with too much material and it bunches up. You can see it. Now you can see there's one there, and there's one there, and that's what they look like on the other side. You can hardly see them. So, all right, I'm going to slip this last one on, and then we'll get this added to our panels. All right, I think we are done. I even went ahead and cut that notch in the back of the center panel when I was screwing it in place, so we should be clear of that power cord. I think we're basically ready to test this. And this guy was an absolute hero again for getting all those screws in. This is the Vessel High Torque little rechargeable ball grip driver. And it is, the only thing I don't like about this is it uses like the older USB charging cable, but outside of that, this thing is great. I'll link it in the description. All right, well, I am liking that. It comes out a little bit further than I thought. I think the whole thing's a bit longer because when I measured the panels, I didn't think about the fact that each one of the hinges was actually going to add about an inch. I had planned for just like a little bit of overhang on the ends, but I actually think that works out really well because this thing's so wide, it's not in my way. So when I'm standing here at the mill, it's not like this panel sticking out past the workbench is going to be in the way. And in fact, it's actually going to block more chips from, shooting over this way and potentially even ending up on that workbench. So yeah, I am really happy with that. The one problem is I can't see the DRO now. And I think I'm just going to lift that up. I thought about actually cutting out part of this panel, but that's silly. This guy's not even at eye level now. I could just simply bring this up like 300 millimeter or so, and I'll be able to see the DRO just fine. So I guess the only thing left to do is let's see if this guy folds up and actually stores the way I wanted. Yeah, that works out great. Easy to grab. I mean, the whole thing is very light because it's mostly just coroplast with a little bit of PLA and TPU, but that stores up there super nice. All right, guys, well, I'm calling that done, and I am really happy with how it came out. Honestly, I'm a bit surprised how well that worked. I knew we'd get there, but I didn't expect TPU to work this well as a hinge. We just keep finding new uses for this material. And I'm also a bit surprised as to how well that actually keys in there at such a small geometry and locks in place. So let me know down in the comments, what ideas does that give you guys, maybe for using TPU as another material in like a part of something that needs flexibility that you can just key in, or maybe as a live hinge for some sort of box or something else like that. I'll of course make the STLs for this available. Even if you're not going to make this, maybe it'd be useful just to kind of steal the geometry for the live hinge part itself, since, I mean, you can make that whatever length you want. I mean, I think the actual geometry is only that 25 millimeters high, and I just modified it in the slicer to be whatever length I needed. The hinge parts, there is a 250 millimeter length of this and a 150 millimeter length, because you do kind of want the screw holes to be in convenient places. I guess from an appearance perspective and from a strength perspective, like we wouldn't want to shrink this. Well, you couldn't shrink it anyway. You wouldn't want to adjust the height in Z because it's going to make the holes oblong and the screws aren't going to fit. So again, I'll make the 250 and the 150 length pieces available, and the TPU piece will just be a short little guy, and you can make it as long as you need it. Guys, as always, thanks for hanging out in the shop with me for this week's design and print. And if this is by chance your first time here on the channel, this is all we do. It's all functional prints like this. No multicolored, new junk of the week. It's all functional stuff like this. A lot of stuff out here in my shop, but I do stuff around the house and out in the yard as well. So if you like that sort of thing, check out some of the other videos on the channel. And if you like what you see, hit the subscribe button. And guys, if you do, I'll see you next Friday.